With Spectro Cloud Palette, deploying Nvidia's software components becomes easier than ever. In this video, we will show you how you can combine the Nvidia DOCA Platform Framework for hardware-accelerated Kubernetes pod networking with the Nvidia Run AI stack for multi-tenant GPU scheduling of AI workloads. First, we will deploy a new cluster that includes the Nvidia DOCA Platform Framework, or DPF for short. The profile abstracts away the complexity of this technology for the end user, boiling it down to just a few variables that you provide during deployment. The defaults already match NVIDIA's reference architecture, making it easy to transition from previous documentation. After the control plane is fully deployed, we enable a switch for hardware-accelerated networking. This installs a component that, on worker nodes, automatically injects a hardware-accelerated network adapter into every pod. Then we complete the process by adding the worker nodes. DPF will automatically detect and configure the DPUs on those worker nodes. Simply wait for the nodes to report as healthy. Workloads on the Kubernetes worker nodes will enjoy line rate network performance for amazing speeds up to 800 gigabits per second. Next, we need some persistent storage for Run AI. DPF only requires basic local storage on the control plane nodes, but for AI workloads, we need something more flexible and performant. In this example, we will use Piraeus from Linbit to aggregate the local NVMe storage in the nodes into Kubernetes native storage. Once installation is complete, we can check the dashboard and see we have several terabytes of storage available. Now we're ready to deploy Run AI, which happens in two stages. The first stage is to deploy the Run AI backend. This is where the central GUI and administration lives. This part can be deployed on any central cluster and doesn't actually require GPUs. But in this example, we will deploy everything onto a single cluster, so it will be co-located with the Run AI workload cluster that we deploy afterwards. Once the Run AI backend is up and running, a new ingress resource will be available to connect to the Run AI web console. We can find it in the Services section on the Cluster Overview tab. After logging in, we will navigate to the Resources tab, where we find the button to deploy a new workload cluster. After giving it a name, Run AI gives us a Kubernetes command to run. However, we are not going to use that command. We only want the 4 values provided on the screen, as those are the values that Palette will ask for when we deploy the Run AI workload cluster profile. To do so, we need to add the Run AI workload cluster profile to the cluster. We could do this by clicking the plus button as we did with the other profiles, but we can also navigate to the profile and click the Deploy button, selecting our DPF cluster as the target. Palette will add the profile to the cluster's configuration, and then we click Save to confirm. At this point, Palette will ask to provide values for the 4 variables that are defined for this cluster profile. We simply copy and paste the values over from the Run AI screen one by one. Once we have all the variables entered, we can click the Apply Changes button to start the deployment of the Run AI workload cluster. This profile contains several components. First, the Nvidia GPU operator, which installs the driver for our GPUs and enables containers to directly use GPU devices. Second, the native operator, which installs a GPU scheduler for sharing GPU infrastructure. And finally, the Run AI workload cluster itself, which registers this cluster and the GPUs to the Run AI backend. Now we can deploy an AI workload. First, we create a 1 terabyte persistent volume that will house our LLM data. Next, we will deploy an inference workload. For this example, we will deploy Llama 3.2 with a 1 billion parameter set. Run AI lets you control how many GPUs are used to run the model. Here, we will select 2 GPUs to get even more tokens per second of throughput. We also select the 1 terabyte persistent volume created earlier to house the data for this model. Then we select the Advanced Setup option. This lets us adjust the parameters of the LLM deployment to account for the specific GPU hardware in our lab and for using multiple GPUs together to run the model. It takes a few minutes for the model to come online, as it needs to download and then load the data into the memory of both GPUs. Once the model is running, we can add a chatbot to interact with the model. All we need to provide is the model name and the internal URL the model runs on. When the chatbot is up, a Connect button is available in Run AI to open the web console. This opens a new window with a chat interface to Llama 3.2. Let's ask it to write a 500-word story about accelerating workloads with Nvidia DPF. And as you can see, with all aspects of the stack accelerated, we are getting great performance from our model. Thanks for watching this demo. To learn more about how Palette can help accelerate your AI projects, visit spectrocloud.com.